Okay, as you can see, I am not there today technically. However, I am on campus. I'm working with Miss Whitley and Miss Doctor on a project that will start on Monday. So I either will be close to you, either in the room next door, or I will be in the front office. Regardless, I will be making rounds to check on you all. So the first thing that I want to do is again go over some housekeeping rules. We're going to go ahead and go over a lesson first, and then towards the end of the class, we will take your quiz. Make sure that you behave, because you know what happens when I get a negative note from the substitute. You are still responsible for the material covered. Even though I am not physically there to explain to you and instruct you on the lesson, you are responsible to view those videos and go over them to make sure that you understand the material. I know that I said we were going to do a foldable for today. However, I'm going to save that and move it to another day sometime in about a week or so to give you the opportunity to get another free 100 pop quiz grade if you do it. Okay, but before we actually start with the lesson, I want to remind you that your homework number 12 is actually due on Monday, and I said that I was going to do problem number 1 with you. Um, Problem number 1 we will do together. You should be able to do problem number 2, number 3, number 4. Number 5 is transformations. You should be able to do that after all, because you should have watched those videos from Wednesday when I was gone. Number 6, you should be able to do that. Take each point and make sure that you do the shifts properly. This number 6 is the only problem that I will allow for you to do it on here. And please don't do every curve or every drawing with the same color, because it gets a little confusing. Make sure that you use a different color for each part that you're doing, A, B, C, and D, so that way I can figure out if it's correct or not, and it'll be easier on my eyes. For the next one, which is number 7, you should be able to tell me the parent function, the domain, and the range. And let's go ahead and skip D, F, and H for right now. That was just getting ahead for the future, but we'll go ahead and save on to those, because eventually we're going to come back to them anyways. So we'll save on to D, F, and H. So go ahead and cross those out. You won't be responsible for that, but you will be responsible for everything else. Again, let me reiterate. Everything should be written on your own separate sheet of paper, with only this one right here, number 6, being able to be done on the actual worksheet. Okay, I'm going to have people that will not follow instructions and give me the wrong style or the wrong way I wanted it. If you give it to me incorrectly, it's going in the trash and it will be a 0. So make sure that you understand what I am asking you to do. Alright, so let's go ahead and go with number 1. This is a piecewise function because it breaks it up into pieces. Okay, this is very simple. The first thing is you got to take it one step at a time. We have this one right here, negative x squared. Now, if you remember, negative x squared is really a parabola that is opening downwards, right? Because of the negative. So it's a parabola that's opening down. So you got to make sure. Let's go ahead and draw it. Okay, so it's a parabola that's opening downwards. Okay, so eventually it looks something like that. However, now I have to consider that I have some stipulations. It's saying that x is less than or equal to negative 1. Okay, so in the meantime, what I'll do is I'll erase this one. This just gives you an idea of what we're looking for. So I'll erase that one. And now I'm going to ask myself, okay, this is less than or equal to that, which means it's inclusive, and it's going to be a shaded circle. So first of all, let's find out what y is when x is negative 1. After all, we can plug it in. So if we were to plug this in, we get a negative negative 1 squared. So when we substitute in this negative 1 squared, it becomes a positive 1. But then we have to be careful because there's a negative here that we have to consider. So it'll still remain a negative 1. So the value when x is negative 1 for y is actually negative 1. So we will have a shaded circle at negative 1, comma, negative 1, which will be right here. Okay, I'm going to go ahead and fill it in. Okay, so that's my shaded circle. So we're going to graph anything that is less than or equal to negative 1 on the x-axis. Well, if you pay attention, this point is already at negative 1 on the x-axis. So the part that we want will either be the parabola that's this half or the parabola that's this half. Well, think about it. Which half is less than or equal to negative 1? I believe it will be the left half. So that will be the piece that I am going to draw right here. So I'm going to draw that piece going downwards like this. And again, it's not drawn to perfection, but it's okay, as long as I get the idea. Okay, so that's perfect. Now it's saying this part right here, the middle, it's x squared if negative 1 is less than x, which is less than or equal to 1. Well, remember, let's figure out what x squared is. X squared is really a parabola that's opening upwards, like this. Okay? However, we have some stipulations. We only want the piece that's between negative 1 and positive 1. So let's go ahead and erase that. So we have an idea of what it's going to look like. So the only possible way to graph this is just by plugging it in. Now let's see. Let's plug in this first value, negative 1. When you plug in negative 1, you get negative 1 squared, which gives you a positive 1. So our y value when x is negative 1 is that it's a positive 1. So I'm going to go ahead and graph that. So when x is a negative 1, y is a positive 1. However, look at the inequality right here. It's non-inclusive, so that means my circle will be open at that spot because we're not including that value for y. Now let's go ahead and substitute this part right here. It's saying that x is less than or equal to 1. Okay, so that means that if I were to plug in 1 in here, 1 squared gives me 1. So when x is positive 1, my y value will be positive 1 as well. But let's look at this inequality. This is inclusive, so that means that my circle will be shaded. So that's exactly what I'm going to plot there. I'm going to plot a shaded circle at 1, 1. Now the question is, I want to graph what's in between negative 1 and positive 1. So let's go ahead and do that. And you'll get the small piece that looks like this. And let's go ahead and make that red and go ahead and make it a little bit thicker. There we go. Okay, so we're almost done. Now this part is saying that negative x squared if x is greater than 1. Well, from the previous one, the first one that we did, you know that negative x squared is a parabola that's opening downwards because of this negative. But this time I want values that are greater than 1. Now look at this inequality. It's a greater than, that's it. So that means it's non-inclusive and it's going to be an open circle. So we take this 1 and plug it in. 1 squared is positive 1 times that negative is negative 1. So when x is 1, we are going to get negative 1 for y. So let's go ahead and plot that. And it'll be right there. Now realize it's an open circle. because of this inequality, not inclusive. Now the question is, I want values that are greater than 1. It's either going to be this half, the left half, or the right half. And if you think about it, the values that are greater than 1 is going to be the right half. So that's exactly what I'm going to draw, which will be this half. Okay, so I'm going to go ahead and make that a different color and add some weight to it. So that is our official piecewise function. Now you should be able to figure out what the range is. So let's look at the range. Range deals with the y-axis, so I'm only concerned with what's going on at the y-axis. So look at your picture. What's the lowest point? And you know what? I'm going to, these right here should have arrows. But what's the lowest point of this function right here? But we know that they continue on and on and on. So technically our lowest point on the y value is the negative portion of the axis, which would be negative infinity. So our range will be from negative infinity, okay? And the way we use negative infinity is we open it up with a set of parentheses. Okay, so our range is from negative infinity. Now let's figure out how tall it goes from negative infinity. So we're going to continue on up. Let's see. It seems like it stops there. And it's going to be to negative 1. So from negative infinity to negative 1. And then there's a break, right? Right here in between is a little gap. And then it starts again from 0 up to 1. Okay, so our range will be from negative infinity to negative 1, inclusive, because this shaded circle replaces this one, so it kind of eliminates each other, so we're going to close it with brackets. And then here, so we're going to also say, and from 0, we're going to include 0, all the way up to positive 1. And again, these cancel out, so we're going to include the positive 1. So your range will have a set of 2 intervals. Now, the x-intercept. Remember, the x-intercept is called x-intercept because it crosses the x-axis. Well, look at your function. It only crosses the x-axis right here. So my x-intercept will be at 0, 0. Or it'll just be x equals 0, since it's asking for the x-intercept. Now, what's the y-intercept? Again, the y-intercept is called just that because it crosses the y-axis. So if you notice again, the only place it crosses the y-axis is at the origin again. So my y-intercept will be y equals 0. Okay, and this is what a piecewise function is. Okay, so hopefully that answered some questions for you all. If you need re-explanation, either go through the video again, or we'll practice some more throughout the week next week. Now what I want to do is go ahead and move on to the lesson, which is going to be called composite functions. It's basically a combination of functions. And basically when you combine functions, you're taking the output of one of the functions, and then you're going to make it an input into another function. So that's basically what it's doing. You're really just combining things. And the formal notation of that is f composed by g of x, which is this part right here on the left-hand side, f composed by g of x, which is really the same thing as saying f of g of x. Now notice how the letters stay in the same order in each expression. Look at the left-hand side, f, g, x. Look at the right-hand side, f, g, x. Same process. And it's read as, from the left-hand side, it's f composed by g of x. The right-hand side is f of g of x. Same thing. Now, an example of composite functions is basically unit conversions. You go through it every day. When you, let's say you are walking or jogging and you know the number of miles that you're jogging, and you know the number of hours that you are jogging, but the question is asking what is your average speed